We're going to start with expressions. We're going to take notes over that, and as we go along, you may need to pause the video so that you can write things down. Here we go. Virginia's SOL Algebra Point 1, the students will represent verbal quantitative situations algebraically and evaluate these expressions for given replacement values of the variables. Vocabulary. A variable is a symbol, usually a letter, used to represent a quantity. This quantity represents an element of any subset of the real numbers. An element or member of a set is any one of the distinct objects that make up that set. For instance, what are the variables in the first example? Variables are x, y, and z. In number 2, what would be the variable? The variable would be the letter b. In number 3, there's actually 2 variables, the variables of b and x. Again, you might want to stop the video so that you may write some of this stuff down. An algebraic expression may contain numbers, variables, operations, and grouping symbols. An algebraic expression may be evaluated by substituting values for the variable in the expression. For example, in this example, we have the expression 5x plus 3y squared minus the square root of 81, where y equals -3 and x equals +5. So if we were to solve this by substituting the values of the expression, we would replace the x and the y with values that will work. So x and y need to be replaced with the 3 and the 5. The next line is written for you. 5 times x plus 3 times y squared minus the square root of 81. You replace the x with -3 and the y with +5. We continue with following the order of operations. We would do the 5 squared first, powers first in the problem. And so we get 25 times 3 plus 5 -3 minus the square root of 81. The next thing would be the square root of 81, since that is a grouping symbol. So we would get 9 for the 81, minus stays in front, 3 times the 25, plus 5 times -3. Then we follow the next step, which would be multiplication. 5 times -3 is -15, plus 3 times 25 is 75, minus the 9. Then we would combine like terms from left to right, and we would get 60 minus 9, and 60 minus 9 is 51. The absolute value of a number is the distance from 0 on the number line, regardless of direction. So if we had a number line on here, and I asked you this value here, -5, what is the absolute value of -5? Written like this, it would equal +5, because the distance from this 5 to 0 is +5. What if it was +6? What's the absolute value of +6? Well, the distance from 6 to 0 is +6. Direction does not matter. Notice in the first one I went 5 to the right to get to 0, and in the other one I went 6 to the left. But we do not count the direction as a positive because it's a distance. When evaluating algebraic expressions, the laws of the order of operations must be followed to find the value of an expression. Solve what is inside the group for p, which is parentheses. E, solve the number to the power for exponents. And multiplication division, solve any multiplication division from left to right. And A/S, solve any addition or subtraction from left to right. Now sometimes I replace this P right here and I call it G for group. Some common grouping symbols: parentheses, brackets, division bar, square root, anything underneath the square root. So it could be lots of things under the square root. So it's not just parentheses, it's also things that group it, like fraction bars, square roots, brackets, anything that will group it, which means you got to get down to a single number, one of these. Another vocabulary term is the square root of a number is any number which, when multiplied by itself, equals the number. Whole numbers have both positive and negative roots. For example, the square root of 25 is 5 and negative 5, written sometimes as plus or minus 5, where 5 is called the positive root and negative 5 is called the negative root. So for instance, if I write a problem and it's written as, what is the square root of, let's say, 121, the answer would be positive or negative 11, or you might write it as 11 comma negative 11. Now sometimes we denote that as just regular notations. So sometimes you want a specific. So sometimes when there's a negative in front of the 121, I really only want the negative root. And sometimes when there's nothing in front of the 121, sometimes we want just the positive root of 11. But a lot of times if I want both things to happen, you might write plus minus in front of the radical 121. Therefore your answer is saying, please give me the positive and the negative answer of 11. Or again, we would write that as 11 comma negative 11. Okay. The cube root of a number n is a number whose cube is that number. For example, the cube root of 125 is 5. So the cube root of 125 is 5 because 5 to the third power is equal to 125, or 5 times 5 times 5 is 125. In general, any number that has been cube rooted and you get an answer of a, that is only true if a to the third power is equal to the n. The following are examples of evaluating expressions containing numbered cubes and just regular examples of how you do a normal cube root of a problem. So when we look at things like 27, square root of 27, you're asking yourself, what number times itself 3 times in a row is going to give you 27? So the 3 numbers that work is 3 times 3 is 9, times another 3 is 27. So therefore, the cube root of 27 must equal the 3. Likewise, if it was x to the cubed, that means x times x times x. So what number times itself 3 times is x cubed? X. So therefore, the cube root of x cubed is just an x. Here's an example of solving a problem with evaluating and with cube roots in the problem. The cube root of 64 plus 5 squared all over 6 squared minus 3. Again, you would follow the order of operations here. So you're looking at your grouping symbols. I see a fraction bar here. Fraction bar separates it. And I see a grouping symbol of the radical, but the radical is above the fraction bar. So we would start probably with the numerator part and the radical of that there. So we would say the cube root of 64, what number times itself 3 times? 4. 4 times 4 times 4 is 64. Plus 5 squared all over 6 squared minus the 3. So then we would continue on there with the problem, and we see that the next logical step would be either the numerator or denominator with powers. So we would end up getting 4 plus 25, because 5 squared is 5 times 5, and 6 times 6 is 36, minus 3, and if we keep going on there from there, 4 plus 25 is 29. Again, we're down to one number on top, and 36 minus 3 is 33. And so we notice that 33 has a multiple of 3 and 11, so we cannot really reduce that into 29 because 29 is prime. So we are simplified. This is a prime number. So since it's prime, we cannot. Next topic. Word phrases, which describe characteristics of given conditions, can be translated into algebraic expressions for the purpose of evaluation. The following are examples of translating word phrases into algebraic expressions or sentences. So the first example here we have is 2 less than the product of a number x and 5. So again, each word means something. So as we go along here, some of the key words I see is the number 2. So that's a little 2 there. Less than's important. The word product, number x, and 5. Okay, so we would say 2 less than. Less than's a special thing that you've already learned, so that means it goes last. So 2 less than, so subtract 2 from the end. Product means multiplication of a number x and 5. So we have the number x times 5 is the product. Now we could write that as, normally we write that as 5x first minus 2, but if we're strictly speaking, the x came first, so I would write that first, then the 5. But a lot of times we just go from there. Next example, 3 times the sum of a number y and 5. So again, important things, 3 times the sum of a number y and 5. So again, those are the important words there. So it's 3 times the sum, 3 times, so dot, the sum is a summation. So since we're talking about the sum, we would put that in parentheses, the sum of what? Of the number y and 5. Again, the word tells you how to write the problem out. So it's 3 parentheses y plus 5. Words like sum, difference, product, and quotient. To be on the safe side, you should put a parentheses around it, just like I did in the last problem. So again, sum is a grouping word. So this is going to go in the group, as we see here. The word product is, again, a grouping word. So again, you might want to put that inside a parentheses as well. I did not. I put the parentheses around 5 and x just so I did not have to show the little dot between them. Like here, there would be a dot between the 5 and the x as times. But with variables, we don't need to show that. The other way of looking at translating is the opposite. You got an example, and then you write it as a statement. There are multiple ways to translate an algebraic expression into a verbal expression. The following are examples of translating word phrases into algebraic expressions or sentences. The square root of 36 plus 5x. So we could just say the square root of 36 plus the product of 5 and a number x. Or we could say 5 times a number x more than the square root of 36. Again, the word more than would make it go from there. You could just be as simple as just say square root of 36 plus 5 times x. That would be another one as well. On this next section is the practice section. So I've written some problems out here, and I want you to solve. What is the absolute value of -5? Write that answer down. Write the problem and the answer down. What is the cube root of 512? What number times itself 3 times is going to equal 512? And it does work out nice. In number 3, I want you to tell me what the variables are in this expression. So we got 3x plus 4y plus 7a plus 10 equals something. The something doesn't matter here. What I want you to do is tell me what were the variables in the expression of number 3. In number 4, we have a expression where we have to use substitution. So the problem or expression is the square root of a plus b to the 3rd power times the quantity c divided by 2. you should put in the numbers of A, B, and C as positive 36, positive 2, and negative 5. Write down the problem, substitute in, and solve for the variable. And last but not least, number 5. 4 less than the quotient of a number x and 5.